Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 35, for broadcast on the 22nd of March, 2023. Coming up on SpaceTime, modern glacier remains found near the Martian equator. Scientists ask the question, where did Earth's water come from? And Europe's CHEOPS planet hunting mission has been extended. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered recent glacial activity near the Martian equator. The groundbreaking announcement delivered at the 54th Lunar and Planetary Science Conference in Texas implies the presence of surface water ice on Mars even in modern times. Known as a glacial relic, it was detected in eastern Noctis Labyrinthus and raises the possibility that ice may still exist there in shallow depths, which would have significant implications for future manned missions to the Red Planet. The relic glacier was one of many light-toned deposits found in the region. Now, typically, these deposits consist mainly of lightly coloured sulfate salts, but this deposit also shows many features of a glacier, including crevasse fields and moraine bands. The glacier is estimated to have been about 6 kilometres long and up to 4 kilometres wide, with a surface elevation ranging from 1.3 to 1.7 kilometres. The discovery suggests that Mars's recent history may have been more watery than previously thought, and that would have implications for understanding the planet's habitability. The study's lead author Pascal Lee, a planetary scientist with SETI, says that his team's discovery wasn't ice, but a salt deposit with the detailed morphologic features of a glacier. So what they think happened is that salt formed on top of a glacier while preserving the shape of the ice below, including details of crevasse fields and moraine bands. The presence of volcanic materials blanketing the region hints at how the sulfate salts might have formed and preserved the glacier imprint underneath. When freshly erupted pyroclastic materials, that is, mixes of volcanic ash, pumice and hot lava blocks, come into contact with water ice, sulfate salts, like the ones commonly making up Mars's light-toned deposits, can form and build up into hardened, crusty, salty layers. And this region of Mars does have a history of volcanic activity. And where some of the volcanic materials came into contact with glacial ice, chemical reactions would have taken place at the boundary between the two to form a hardened layer of sulfate salts. At least that's the most likely explanation for the hydrated and hydroxylated sulfates observed in the light-toned deposits. Over time, with erosion removing the blanketing volcanic materials, a crusty layer of sulfates, mirroring the glacial ice underneath, became exposed. That would explain how a salt deposit is now visible, preserving features unique to glaciers such as crevasses and moraine bands. Importantly, the glacier's fine-scale features, its associated sulfate salt deposits, and the overlying volcanic materials are all very sparsely cratered by impacts, and that means it's still a very geologically young surface. Now, don't get me wrong, scientists have known about other Martian glacial activity in many locations, including near the equator. But they're all much older, dating to a much earlier time. And they've also known about more recent glacial activity on Mars, but that's only ever been seen at much higher latitudes. A relatively young relic glacier at this location tells scientists that Mars must have experienced surface ice in recent times, even near the equator, and that's the new information. It remains to be seen whether water ice might still be preserved underneath the light-toned deposit, or if it's disappeared completely. Today, water ice isn't stable on the Martian equatorial surface at these elevations, so it's not surprising that scientists aren't detecting any water ice at the surface. It's very possible that the glacier's water ice sublimated away by now, but there's also a chance that some of it might still be protected at shallow depth under the sulfate salts. If there is still water ice preserved at shallow depths at a low latitude on Mars, that would have serious implications for future science missions as well as long-term human exploration. The desire to land people at a location where they might be able to extract water ice from the ground has been pushing mission planners to consider higher latitude sites. Problem is, the higher latitude environments are typically much colder, therefore more challenging both for humans and for robotic missions. On the other hand, if there is an equatorial location where ice might be found at shallow depth, then missions have the best of both environments. Warmer conditions for people to explore, but still with access to water ice. This is SpaceTime. Still to come. While we continue the hunt for Martian water ice, the question remains, where did Earth's water come from? And the European Space Agency have extended the CHEOPS planet hunting satellite mission. All that and more still to come on SpaceTime. Water makes up 71% of the Earth's surface. Trouble is, no one really knows how or when such massive quantities of water arrived on Earth. It's an important question because water is essential for life as we know it. And here on Earth, wherever you find liquid water, you'll also find life. We know water is common throughout space and right across our solar system. Even the Earth's moon has water, frozen at the bottom of deep shadowed craters where sunlight never reaches at the lunar poles. And we know the water found in comets contains the wrong hydrogen to deuterium ratio to be the source of Earth's water. That ratio changes depending on how far away from the sun the water originated. So, not comets, but asteroids and meteors, some of which do have the right hydrogen to deuterium ratios to be a likely source for Earth's water. But not all. Now, a new study published in the journal Nature brings scientists one step closer to answering that question. Where did Earth's water come from? To solve the problem, scientists have been analysing meteorites that have been floating in space ever since the solar system's formation 4.6 billion years ago. But they found some of these meteorites had extremely low water content. In fact, they're among the driest extraterrestrial materials ever measured. These results, which let researchers rule them out as a primary source of Earth's water, could have important implications for the search for water and therefore life on other worlds. It also helps researchers understand the unlikely sorts of conditions which must have aligned to make Earth a habitable planet, one on which life could survive. The study's lead author, Megan Newcomb from the University of Maryland, says she wanted to understand how Earth managed to get its water because it's not completely obvious. Getting water and having surface oceans on a planet that's relatively small and near the sun is a huge challenge. Newcomb and colleagues analysed 7 achondrite meteorites, which crashed to Earth billions of years ago after splitting off from at least 5 different planetesimals. The authors used an electron microprobe to measure levels of magnetism, iron, calcium and silicon in their meteorite samples, and they then measured their water content using a secondary ion mass spectrometer. The challenge of analysing water in extremely dry materials is that any terrestrial water on the surface of the sample, or inside it for that matter, can be easily detected, thereby tarnishing the results. So to reduce this contamination, the authors firstly baked their samples at a low temperature in a vacuum oven in order to remove any surface water. Now, before the samples could be ionized in the secondary ion mass spectrometer, the samples had to be dried out once again, this time by being placed in a vacuum chamber under a turbo pump for more than a month in order to literally draw out as much of the terrestrial water as possible. Now, some of their meteorite samples came from the inner solar system, the same part of space where the Earth is located and where conditions are generally assumed to have been warm and dry. Other rarer samples came from colder outer reaches of the solar system, beyond the so-called snow line between Mars and Jupiter. While it was generally thought that water came to Earth from the outer solar system, it's yet to be determined what types of objects could have carried that water across the vast expanse of space. After analysing the achondrite meteorite samples, the authors discovered that water comprised less than 2/1,000,000th of their mass. Now, for comparison, the wettest meteorites, that's a group known as carbonaceous chondrites, contain up to 20% water by weight. That's 100,000 times more than the meteorite samples studied by Newcomb and colleagues. Now, all this suggests that the creation of planetesimals leads to near total water loss, regardless of where these planetesimals originated in the solar system and how much water they started off with. The authors concluded that the water must have arrived at Earth by way of unmelted chondritic meteorites. This is SpaceTime. Still to come, the European Space Agency has extended the CHEOPS mission until at least 2026 and possibly 2029, and later in the science report, a new study claims a Mediterranean type of diet could help lower your risk of developing dementia. All that and more still to come on SpaceTime. After more than 3 years in orbit, the European Space Agency's CHEOPS mission has been extended until at least 2026 and possibly 2029. Since its launch back in December 2019, the spacecraft's extremely precise measurements have contributed to numerous new exoplanetary discoveries, that is, planets orbiting stars other than the Sun. And the extension of this mission will make it possible for astronomers to study these distant worlds in more detail. Unlike previous planet-hunting spacecraft, such as Kepler and TESS, which are designed to observe tens of thousands of stars simultaneously, watching for a sudden change in brightness in a star caused by a planet passing in front of or transiting that star, CHEOPS has been optimized to observe a single star at a time, and it targets stars already known to host exoplanets. CHEOPS measures changes in the brightness of a star, known as a light curve, as a planet passes in front of that star. The aim of CHEOPS, therefore, is to go beyond a mere census of exoplanets and measure some of their key characteristics, in particular their size, with exquisite precision. By measuring changes in how a star's light is curved by a transiting planet, CHEOPS can determine the size of the planet, and therefore for its density to be determined on the basis of other data such as its mass. Dense planets, like say the Earth, are mostly composed of rocks and metals, while planets with low densities, like Jupiter or Saturn, are mostly made out of gas. Still others with a density of water could be ocean worlds. This in turn is an important step in determining whether a planet has the sorts of conditions that could be hospitable for life. Since these compositions are the result of the planetary formation process, getting to know them opens a window on the past history of planetary systems, putting our own solar system in context. For example, by closely observing how the luminosity changes as the planet WASP 103b passes in front of its star, scientists have determined that this planet is deformed into the shape of a rugby ball due to the extreme gravity of the nearby star. Now, planets like this are so hot that CHEOPS has also been able to detect them glowing along their orbit around their host star. The glow detected by CHEOPS for the planet WASP 189b is only a few millionths of the light emitted by the host star, and it's related to the temperature of the planet's atmosphere and cloud cover. CHEOPS' primary mission was planned to last 3.5 years, ending this September. But the outstanding quality of the science produced by the mission, as attested to by the publication of more than 50 scientific papers, clearly called for a mission extension. Importantly, the spacecraft is still in good condition, despite the harsh space environment where it's constantly bombarded by cosmic rays and high-energy radiation. Mission managers say they've only scratched the surface of the capabilities of CHEOPS. There's much more science to do. Another unique characteristic of CHEOPS is its ability to combine forces with other space missions, such as the James Webb Space Telescope. CHEOPS can refine science's knowledge of already known exoplanets in order to select the best candidates to be observed with Webb. Thanks to CHEOPS's observations, astronomers used Webb to observe the planets in the TOI 178 system in order to determine their atmospheric composition, and that in turn will help scientists understand the dynamical history of the entire system. NASA's Planet Hunting TESS Observatory originally discovered 3 planets orbiting the star TOI 178. But when CHEOPS looked at the same system, it discovered 3 more and revealed an outstanding and fragile orbital harmony, leading astronomers to hypothesize that it's been unperturbed for billions of years. Led by the University of Bern in collaboration with the University of Geneva, CHEOPS, which stands for Characterizing Exoplanet Satellite, is a joint mission by the European Space Agency and Switzerland.
This joint mission is solely dedicated to the study of planets orbiting around bright nearby stars. After over 3 years of successful operation since its launch in December 2019, the CHEOPS mission has been extended for at least 2 more years by the European Space Agency.
I was absolutely thrilled to learn the news of the extension of CHEOPS.
Well, I'm very happy, of course.
I was relieved to know that the extension was granted.
Because it means that this extremely good work and these very exciting discoveries that we have been able to do for almost 3 years now, we will be able to continue them.
We invited some experts from the very heart of the CHEOPS team to understand how important the extension is and what results it could give in the future.
So first of all, the fact that CHEOPS is performing today as it was performing 3 years ago already tells you that, of course, it needs to continue flying because it's as good as new. It hasn't done all the science that it could do.
CHEOPS is a more precise instrument than many others, and therefore we get to measure different things, better things than the others.
CHEOPS is special in that, in contrast with previous space mission, its goal is not to detect more of these exoplanets, and we know so far almost 5,000 of them, but to obtain the more detailed knowledge, what we call characterization, of the most interesting of these exoplanets.
So CHEOPS is the very first small satellite in ESA's scientific program.
That was designed to characterize exoplanets.
Which means to determine their nature, their composition, and if they have an atmosphere.
So this is what I find extraordinary in this business, to be honest, is you can say how big a planet is, you can say constrain its atmosphere, you can say all these things, but you never see the planet.
We are looking at the star. What we see is that then the light we receive from the star decreases. Measuring how much this decrease is allows us to know the size of the exoplanet.
Because we only observe when the planet is passing in front of its star. So if it does so every year, it means that you need to wait another year to observe it. Now, if we want to have much more data, it means that we need to extend our coverage in time so that we have more opportunities to see any fantastic planets coming back into our field of view.
Indeed, for 3.5 years, the precision of CHEOPS has exceeded all expectations. It has allowed scientists to determine the properties of a vast number of exoplanets, some of which being particularly unusual.
CHEOPS measured a planet that is not spherical, but has the shape of a rugby ball.
Because it was orbiting so close to the star that it got deformed by the tidal forces between the star and the planet. So you can detect the fact that the planet is not spherical but deformed because of the tides. I think this is again quite remarkable to have enough precision to detect those things. And one of the highlights is clearly this system TOI 178 with 6 planets in a Laplace resonance.
It's exactly the same as a harmony on a musical score. Because these systems are fragile and they exist today, we can observe them, it means that for billions of years, a system like that has remained unperturbed.
Although CHEOPS' main objective was the characterization of exoplanets, CHEOPS is a photometer, so it means that it can do all the kinds of photometric measurements. And it can also do solar system objects. As you may know, CHEOPS has recently contributed to the discovery of the rings of the dwarf planet Quasar.
And what was very special with this disk, it is very relatively far away from the object, much further away than one thinks these disks should normally be. So, as usual, when you try to solve a problem, you find new ones to address. So now we have a disk, but we don't know how come this disk can exist where it is. So, it opens new questions.
So as we see, the extension of CHEOPS is crucial for understanding the unique worlds far beyond our solar system. But what other riddles do scientists expect to solve with CHEOPS in the future?
One thing that we could expect, and that would be really thrilling, would be the detection of the first moon around an exoplanet, what we call an exomoon. In the solar system, there are hundreds of moons around giant planets, but our Earth also has a very prominent natural satellite, the moon.
The signal of an exomoon is very small even compared to the signal of an exoplanet. So detecting that will require a lot of observation.
This is also a little deformation of the light curve that we expect to be able to see if the moon is big enough. So far we haven't seen anything, but we're trying.
For CHEOPS, without any hint that we could find an exomoon, it will be a lot of time invested where maybe there is no return. However, there are particular candidates where we suspect there could be an exomoon, and we are dedicating time to look for it. But the fact that the signal is so small makes it hard.
Well, exomoons and exorings and all that thing is something that is of course of interest. But it is a bit fishing expedition that you don't really know whether you're going to find it. So we have built a much more solid science program where we know we will get results. So there are many things building on what CHEOPS does best, characterizing planetary systems. This is really important because many of those planets in these systems become prime targets for other big space infrastructure. And that's why science is so important, that we collect data and compare data and have enough data. And that's why we need more and more and more, because every time you realize that what you knew before is not the complete story.
And in that report from the University of Bern, we heard from CHEOPS instrument scientist Dr. Andrea Fortier, CHEOPS principal investigator Professor Willy Benz, and CHEOPS science chair Professor David Renrich. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims that eating a Mediterranean type of diet, one rich in seafoods, nuts and fruit, could help lower your risk of developing dementia. The findings, reported in the British Medical Journal, looked at more than 60,000 people, finding that the risk of developing dementia was 1.18% among people who stuck to a Mediterranean diet, compared to 1.73% among people who didn't, which equates to a 23% lower risk. Meanwhile, research reported in the Journal of Cancers by the University of South Australia has shown that men who stick to a predominantly Mediterranean diet are less likely to be diagnosed with prostate cancer. Scientists also found that the diet improved their chances of recovery if they did have prostate cancer and are undergoing radiation treatment. Scientists have discovered the DNA sequence of a gene in wheat responsible for resisting a devastating plant virus. The new findings provide vital clues for managing more resistant crops and maintaining a healthy food supply. Wheat crops across the Americas, Asia, Europe and Africa are frequently ravaged by wheat yellow mosaic virus. So there's a high demand for wheat varieties or cultivars that can resist this virus. Now, a report in the journal PNAS claims scientists have found that the resistant gene originated in an ancient Mediterranean wild plant relative of wheat. A machine learning method that sifts through telescope data could one day help detect radio signals likely to have originated from an alien life form. The study's authors used the method to search through more than 480 hours of data from the Green Bank Radio Telescope, a process usually made extremely time-consuming because of all the interference caused by human technology. A report in the journal Nature Astronomy says the method produced some 20,515 signals of interest for scientists to sift through, which is more than 100 times less than previous analyses of the same data had come up with. The authors say this method could make identifying strange radio signals more efficient, speeding up the search for extraterrestrial intelligence. OpenAI ChatGPT-4 has now been released, providing a far greater database for the artificial intelligence chatbot. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Well, it's the newest version of the generative pre-trained transformer. Version 3.5 was said to use billions of pieces of information. ChatGPT 4 is said to use trillions of pieces of information. So the answers it can give are richer, better, smarter. But of course it can still get things wrong. I mean, it can now accept images as input. And you can actually have the voice, the results can be spoken to you. I mean, it won't be long before you'll just speak to it as well. I mean, you can already do that. You don't have to type things into your phone. You can just tap on the microphone. But it is the beginning of a more intelligent AI. Microsoft's Bing Search AI.
It's still going to take a while, I think. I wanted to see if it could write a news story for me, just as a test, and it did. It wrote the story, but it wasn't very good. The sentence structure was all out. The storyline wasn't the way it should be for a piece of journalistic work. So I think it's still got a way to go, but it's still a baby and it's still learning, and I understand that.
Well, that's all true, but I mean, the progress has been incredible since ChatGPT 3.5, the chatbot, was launched in November. There have been people using earlier versions of ChatGPT. There was even a Reddit thread that was unbeknownst to anybody. I mean, some people figured it out, but it was being all answered by, I think, ChatGPT 3 at the time. So version 4, less than sort of 3 months or so, just under 4 months that this new version has come out. And already people have been able to compress and use the source code for Facebook's Llama chatbot and get it running on a smartphone slowly, but get it running on a Mac a bit faster, get it running even on a Raspberry Pi. And this is a personalized ChatGPT bot that lives on your device. It isn't being programmed by somebody else. So there's going to be a big rise in these things. It's become open source. Facebook didn't launch the weight that give it the information it needs, but then somebody leaked them on BitTorrent and then the community's gone crazy. So there's multiple things happening on multiple fronts in AI. And, we all know how frustrating it can be to use Siri, Google, and Alexa. You ask it things it doesn't quite understand. Talking to ChatGPT is on another level, and it does make crazy mistakes. It has told me false information about certain sci-fi books I've asked it about. I've asked it to give me breakdowns of what the story was about, and it's conflated books together. It's done a great job in imagining sequels, for example, to what might happen after Foundation in Earth, the last book in Asimov's series that he wrote. I mean, there were other books written by the people, even an unauthorized sequel, which ChatGPT and Bing Search AI both knew about. And they wrote pretty incredible summaries of what a future sequel might have been like, whilst also sort of saying we have to respect Isaac Asimov's estate, and this is just a suggestion. But it's pretty impressive, and it's only going to get better. And we're barely 4 months into the AI revolution having dropped the same way the iPhone did in 2007 and changed the world.
Stand by for Skynet.
Well, that's the thing. I've always said science fiction movies, especially dystopian ones, are warning letters to humanity to not let that scenario happen to us. We've seen what can happen, and we should be smart enough to stop that from happening or to avoid suffering that fate. Let's hope we learn the lesson.
That's Alex Zaharov-Reut from ITWire.com. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.